What if I told you that every winter when you sprinkle salt on ice, you are not just melting it. You're quietly breaking one of nature's most fundamental rules. And the strangest part? Most people, including students, teachers, even science lovers, have been explaining it wrong this entire time. Because salt doesn't actually melt ice. So what is it really doing? To understand this, we need to forget everything you think you know and start from something much deeper. Imagine a single ice cube, solid, still, frozen. At first glance, it looks perfectly calm, almost lifeless. But at the microscopic level, it's chaos. Water molecules are locked into a rigid structure, like millions of tiny soldiers standing in perfect formation, each one vibrating, but not free to move. That's what makes ice solid. Now, here's the twist. Even at temperatures below freezing, not all of the water is actually frozen. There's always a thin, invisible layer of liquid water on the surface. Yes, even on ice. This layer is incredibly important because it's where everything changes. Now, let's introduce salt. You sprinkle it onto the ice, and instantly something strange begins to happen. The ice starts disappearing. And naturally we say salt melts ice. But that explanation is incomplete, because salt isn't adding heat. It's not making anything warmer. So how can something melt without heat? This is where physics gets uncomfortable, because what salt actually does is interfere with the rules that allow ice to exist in the first place. You see, ice forms when water molecules arrange themselves into a stable, repeating crystal structure. But salt breaks that structure. When salt dissolves into that thin liquid layer, it splits into charged particles, ions. These ions sneak between the water molecules and disrupt their ability to lock into place. It's like trying to build a perfectly organized army while someone keeps pushing soldiers out of formation. The structure collapses, not because it's heated, but because it can no longer exist as a solid. And here's where it gets even more disturbing. Salt doesn't just melt ice, it lowers the freezing point of water itself. In pure water, freezing happens at 0 degrees Celsius. But when salt is added, that freezing point drops. -5 degrees, -10 degrees, even lower depending on how much salt you use. Which means something incredible. At temperatures where ice should exist, it suddenly can't anymore. Think about that. The laws of nature haven't changed, but the conditions for reality have shifted. Ice isn't melting because it's warm. It's melting because the definition of frozen has been rewritten. Richard Feynman once emphasized something powerful. If you think you understand something, but you can't explain it simply, you don't really understand it. And this is a perfect example. Because salt melts ice sounds simple, but the truth is far more unsettling. Salt doesn't melt ice. It forces water into a state where being ice is no longer possible. And there's a deeper lesson here. Physics isn't always about adding energy or removing it. Sometimes it's about changing the rules of the system itself. tiny particles, invisible forces, quietly deciding what can exist and what cannot. So the next time you see salt spread across a frozen road, don't just see melting ice. See a microscopic battlefield where structure is breaking down, where order is collapsing, and where physics is being bent in ways you were never taught. Because reality isn't always what it looks like. Sometimes it's far stranger and far more fragile than we ever imagined.